Hi everyone. Today I am going to solve previous year's questions in potentiometer. If you want clarity in theory, you can go through the link that I provided in the description. మనం ఇప్పుడు ఫస్ట్ క్వశ్చన్ చూద్దాం. A potentiometer wire AB having length L and resistance 12R is joined to a cell D of EMF E and internal resistance R. Yeah. In the first sentence he gave about main circuit. So that is the thing. Right. So what he gave, length of the wire AB as L and its resistance as 12R. Yeah. He also gave main circuit cell EMF as E and its internal resistance as R. Let us see next. Yeah. A cell C having EMF E by 2 and internal resistance 3R is connected. Yeah. Where it is connected? In the sub-circuit. So in the second sentence, he is giving about sub-circuit. Right. Yeah. So he gave sub-circuit cell EMF as E by 2 and its internal resistance as 3R. Right, let us see next. The length AJ at which the galvanometer as shown in figure shows no deflection is. Yeah, he is asking us to find length AJ, that means LAJ, at which galvanometer shows zero deflection. That is the thing. Yeah, potentiometer working principle ఏంటి? When the galvanometer shows zero deflection, the cell EMF becomes equal to potential difference between, yeah, which cell EMF? Sub-circuit cell EMF becomes equal to, yeah, potential difference between junction and moving contact J. So that is the thing. That means here ESC becomes equal to VAJ. So that is the thing, right? Yeah. Let us say I0 is a current flowing through the main circuit, right? So from Ohm's law, VAJ is equal to I0 into RAJ, where I0 is main circuit current, RAJ is resistance of the wire between A and J. So that is the thing. ESC he gave how much? E by 2. So E by 2 is equal to I0 RAJ. So let us take it as equation 1. Right. So in order to obtain main circuit current I0, so we need to apply KVL to the main circuit. Right. In the main circuit cell and wire AB are connected in series. Let me draw the electrical equivalent of the main circuit. So he gave main circuit cell parameters E and R. And he also gave, yeah. So what is that? Wire AB resistance. How much? 12R. So we already assume I0 is the current flowing through the main circuit. Right. So when we apply KVL, what we are going to get? E minus I0 into 12R minus I0 R is equal to 0. So E is equal to, here you can see 12 plus 1, 13. So I0 into 13R. So I0 is equal to E by 13R. So that is it. So when we substitute into the equation 1, what we are going to get? E by 2 is equal to E by 13R into RAJ. So that means RAJ is equal to 13R by 2. So let me take it as equation 3. So he also gave RAB as 12R. So that is known. So let us take these two into next slide. So RAJ is equal to 13R by 2. Right. So RAB is equal to 12R. So this we already taken as equation 3. So this is 3 and this is, let us take it as 4. But we know resistance of the wire as R is equal to rho L by A. That means resistance of the wire AJ is going to be how much? RAJ is equal to rho LAJ by A, where LAJ is the length of the wire between A and J. Similarly, RAB is equal to rho LAB by A. So, but he gave what is LAB? So, length of the wire AB. So, we can see that is L. Yeah. So, when we substitute, what we are going to get? RAB as rho L by A. Right. So, when we take equation 3 by 4, so what we are going to get? RAJ by RAB. So, is equal 13R by 2 by 12R. So RR goes. So we are going to get, yeah. So this is 13 by 24. But we know these things, RAJ, RAB. When we substitute what we are going to get, rho LAJ by A, rho L by A. So here rho by A common is equal 13 by 24. So that means LAJ is equal to 13 by 24. Yeah. Right. So we got LAJ as 13L by 24. So which option is satisfying? Let us see. Yeah. So option C is the correct answer. Let us see next question. Yeah. The resistance of the meter bridge AB in given figure is 4 ohm. So he gave resistance of the wire AB. So that is how much? 4 ohm. Meter bridge AB means the length of the wire AB is 1 meter. That's all. Nothing much is there. Right. With a cell of EMF E is equal to 0.5 volts and rheostat resistance RH is equal to 2 ohm, the null point is obtained at some point J. That means when cell EMF is equal to 0.5 volts, rheostat resistance is equal to 2 ohm, the null point is obtained at J. So that is the thing, right? Let us see next. When the cell is replaced by another cell of EMF E is equal to E2. Yeah. When cell is replaced by another cell of EMF is E2, the same null point J is found for RH is equal to 6 ohm. Same null point is found for RH is equal to 6 ohm. Here we have to notice that the potentiometer experiment is performed 2 times. Okay. Once with cell of EMF, what is that? 0.5 volts. Other with other time with cell of EMF E2. That is the thing. Right. So let us take this as case 1. This is case 2. Yeah. The EMF E2 is, he is asking us to find E2. Yeah. Potentiometer working principle ఏంటి? Yeah. When the galvanometer shows zero deflection, EMF of the cell becomes equal to potential difference between A and J. So that is the thing. So that means E is equal to VAJ. So let us say I0 is the current flowing through the main circuit for the first case. So then VAJ from Ohm's law becomes I0 into RAJ. So where I0 is main circuit current, RAJ is resistance of the wire between A and J. That's all. Right. Let me take the equation 1. In order to obtain main circuit current I0, we need to apply KVL to the main circuit. So that is the thing. Right. So in the main circuit, you can see battery, wire AB, and rheostat are connected in series. So what is the resistance of wire AB? That is 4 ohm. For the first case, what is the rheostat resistance? 2 ohm. Battery voltage he gave 6 volts. So we assumed the current flowing through the main circuit for the first case is I0. So when we apply KVL, what we are going to get? 6 minus I0 4. Yeah. Minus I0 2 is equal to 0. So 6 is equal to 4 plus 2, 6 I0. So I0 is equal to 1 ampere. Let me take it as equation 2. So that is the thing. Right. Yeah. So now let us consider second case. Let us say in the second case, yeah, I0 dash is the current flowing through the main circuit. Yeah. So right, in the main circuit, we know already battery, wire AB, and rheostat resistance are connected in series. So this is 4 ohm. For the second case, what is the rheostat resistance? 6 ohm. Yeah, when we substitute battery voltage, we know. So we already assumed I0 dash as the current flowing through the main circuit of second case. So when we apply KVL, what we are going to get? 4 I0 dash, sorry, 6 minus I0 dash into 4 minus I0 dash into 6 is equal to 0. So 6 is equal to I0 dash into 10. So I0 dash is equal to 6 by 10. Yeah. So let me take it as equation 3. So when we apply potentiometer principle to the second case, what we are going to get, E2 is equal to, let us say Vaj dash. So Vaj dash is equal from Ohm's law, I naught dash into Raj. Yeah, so let us take it as equation 4. So we already wrote equation 1, E is equal to I naught Raj. Here we have to understand that the null point is coinciding for the two cases. Yeah, so that is the thing. So that's why Raj is common. Yeah, when we take 4 by 1, what we are going to get? So E2 by E is equal to I naught dash by I naught. So E2 is equal to I naught dash by I naught into E. So we have I naught dash 6 by 10. What is I naught? You can see I naught and E. I naught is 1 ampere. E is equal to 0.5 volts. So let us substitute 0.5, 1. So 0.5 is nothing but 5 by 10. Yeah. So 30 by 100. So 0.3 volts. Yeah. మనకి E2 ఎంత వచ్చింది? 0.3 volts వచ్చింది. ఏ ఆప్షన్ సాటిస్ఫై చేస్తుందో చూద్దాం. Yeah. Option B is satisfying. So option B is the correct answer. Right. Today I have solved 2 previous year's questions. Thank you.